Imagine you are trying to teach a machine learning model to make predictions, but some of your data points are measured in thousands, while others are mere fractions. This difference in scale can cause quite a bit of confusion for your model, making it difficult to learn effectively. It is like trying to compare apples and elephants without adjusting for their vastly different sizes. Min-max scaling is a data preprocessing technique that addresses this very challenge by transforming numerical features to a common scale, typically between 0 and 1. Its primary purpose is to normalize the range of independent variables, ensuring that no single feature dominates the learning process simply because of its larger magnitude. The core mechanism behind min-max scaling is a straightforward linear transformation. For each feature, it subtracts the minimum value of that feature from every data point and then divides the result by the range, which is the difference between the maximum and minimum values. This process effectively rescales all data points into a predefined interval. The formula is quite elegant. A transformed value equals the original value minus the minimum value, all divided by the maximum value minus the minimum value. This ensures that the smallest value becomes 0 and the largest value becomes 1, with all other values falling proportionally in between. To apply min-max scaling, you would typically calculate the minimum and maximum values for each feature in your training dataset. It is crucial to use only the training data for these calculations to prevent data leakage. Once you have these minimum and maximum values, you then apply the same transformation to both your training and test datasets. This ensures consistency and prevents your model from learning anything from the test set before evaluation. An important detail to remember is that min-max scaling is a specific type of normalization known as feature scaling. It is a linear transformation, meaning it does not change the distribution shape of the data. However, it is highly sensitive to outliers. If your dataset contains extreme values, these outliers can significantly distort the minimum or maximum, compressing the majority of your data into a very narrow range. Because of this sensitivity, it is often wise to handle outliers or consider alternative scaling methods like standardization, also known as z-score normalization, if your data is prone to extreme values. By uniformly adjusting the scale of your features, min-max scaling provides a significant advantage for many machine learning algorithms. Models that relying on distance calculations, such as k-nearest neighbors or support vector machines, perform much better when all features contribute equally. Similarly, gradient descent-based optimization algorithms, commonly used in neural networks, converge faster and more stably when data is scaled. This careful preparation ultimately leads to more robust, accurate, and efficient machine learning models.